Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. We've got another customer requested topic today. Here it is. Tank volume user-defined function block from a data table. So a while back, we did a series of user-defined function blocks that allowed users to calculate tank volume based on tank geometry. So in other words, if you had a tank of a certain shape and you wanted to know how many gallons of liquid was in the tank, or maybe how many liters was in the tank based on the level of liquid in that particular tank, that's what those user-defined function blocks did for you. Now, I've had a conversation with a customer about that. He said, wow, those were useful UDFBs, except sometimes a manufacturer will have a tank that doesn't fit a set geometry. And so what they'll do is they will post a table of level versus volume so that you can calculate gallons or liters that way. And he said you really need a user-defined function block for handling that use case as well. So here we are. All right, so that's what we're going to do today is we're going to handle that use case. So without further delay, let's get right to it and break down today's topic. Okay, in case you've been under a rock for the last couple of years, we're going to start with just one slide explaining what user-defined function blocks are and what they're good for. And then we'll do a quick review of those previous tank volume UDFBs we did that were based on tank geometry. Just a real quick review. But we're going to spend most of our time today reviewing this new user-defined function block that's going to allow you to take that manufacturer's data table that has level and volume listed and figure out based on your level and your tank what your gallons or liters correspond to. And there'll be plenty of demonstrations as we go along. All right, here we go. So what are UDFBs? Again, this is for you folks that might have been under a block for a while, or under a rock, I should say, not a function block. But user-defined function blocks are sections of logic that have been transformed into a function block with inputs and outputs, just like a regular function block that might be native to an instruction in Cscape or any other logic editor. Now, UDFBs are saved in a portable file format and they can be imported into your project. So if you create a user-defined function block yourself, which you can absolutely do, and we've had several videos on that, you can then, after you've created it and tested it, you can then save it in a file format or export it, as they say. And then on a future project, you can import that function block back in, and you can use one or many instances of that function block in your project. So they can be extremely useful. Now, sometimes you have user-defined function blocks that you've created. Other times you'll use user-defined function blocks that are available from others, like Horner Automation, for instance. We make them available on our website, usually tied to our videos, so that you can use those in your projects. Now let's take a quick look at the user-defined function blocks that we did a while back that allowed you to calculate gallons or liters or percent full of a tank based on its geometry. And on the screen here, you can see 6 different tank geometries for which we created user-defined function blocks. Now, what we found out, of course, or what we knew going in, frankly, is that not all tanks are of a common geometry. And as I mentioned in the open, what some manufacturers will do if they've got kind of a custom geometric shape or a custom tank is they'll publish a data table. And you can see an example of one there on the screen. So we've got a tank that has a column in level, in this case inches. Okay, it could also be in centimeters. You can find it both ways. And then another column is in gallons. In other words, at 1 inch, you've got 6 gallons of liquid. All the way up to the end, where at 27 inches, when the tank is full, you have 275 gallons of liquid. And you can see the corresponding levels and their volumes listed in that entire table. So what we're going to do is we're going to show you how to take a manufacturer's table like this, and then by using a user-defined function block that I've created, you can utilize that, import that into your project, and then basically calculate very accurately the amount of liquid in your tank based on level in terms of course, gallons or liters or in percent full of the tank. Okay, so effectively, what would be involved in doing this exercise if you were going to do it from scratch yourself? Basically, what you would need to do in your logic is you would need to find, based on your current level reading, whatever that happens to be, you would need to take your current level reading, maybe coming from a sensor, convert that over to, either inches or centimeters, depending on what units your table is expressed in. Okay, and then you would need to find on the chart, you would need to find the closest entries that are around your current fill level. Once you've done that, you would take those entries or the data from those entries and perform linear interpolation to find the closest estimation of volume based on your level. So there in red there on the screen, you can see that we've got a theoretical level of 12.5 inches. Okay, so we would use the readings in the table or the entries in the table that are around 12.5. 12 is below and 13 is right above. And we can see that correlates between 119 and 131. Okay, so, mentally in our head, we could say, okay, if we're at 12.5, we're halfway between 12 and 13 inches. So the number of gallons would be halfway between 119 and 131. So that's basically what we're talking about here. And then once we've retrieved that value, if we're interested in converting that, from gallons to liters, we could do that in case we wanted to provide both readings. The other thing we could do is we could calculate based on the total capacity of the tank, how full it was, what percentage full it was from 0 to 100%. Okay, so that's really what's involved. Now, it'd be a lot easier. And as the one who basically programmed this user-defined function block from scratch, I can tell you it's going to be a lot easier for you to use my user-defined function block than for you to do all this logic from scratch. Certainly this is possible because I did it, but it's much easier to use the UDFB. Okay, so let's take a look at the UDFB that I've created. Remember, a user-defined function block is, at its heart, it's just a function block that has inputs and outputs. All right, let's take a look at the inputs of the user-defined function block, which are highlighted there on the left. Okay, now a big question you may have is, how would you get data table information into your logic? Well, the answer is you're going to do it in the form of two arrays. One array for the column of level data, in inches or centimeters, and another array for the column of volume data, either gallons or liters, for instance, okay? So you're going to specify, what array as an input represents level and what array as an input represents volume. And in the case of this user-defined function block, those are arrays of real values, okay? All right, and then you've got three other inputs as well. The next input is your table size. That's just an integer. What does table size represent? Well, that represents how many different rows of data are in your table. And in the example I'm using today, with that table that I showed on the previous page, there were, if you would have counted them, there were actually 27 rows of data. Okay, so table size in the case of that example would be an integer value that has a value of 27. Now you need to enter that as a variable. You can't just type 27 in as an input to that user-defined function block. You need to assign it as a variable and set that variable to a value of 27. Again, 27 being my example size here, but it can be any value up to 100. This user-defined function block has been defined to handle arrays up to 100 each. So that would be up to 100 rows of level data and up to 100 rows of volume data. All right, after table size, you have your fill height variable. What is your fill height variable? Well, that is the actual level in the tank that you would measure. Okay, so what that means is outside of this function block, you would have a little bit of logic that took the data from your sensor. Maybe it's an ultrasonic sensor, for instance, that's measuring the level of liquid in the tank. And you would need to convert that to centimeters of liquid in the tank. Okay, that's what you would need to do there. All right, so fill height is another real value that correlates to the liquid in the tank in the same units that your table is expressed in. So if your table is in inches, your fill height would need to be in inches, for instance. And then there's one more input that is just a Boolean on or off. And that is a variable that if it's on, it means that your table is in metric units. If it's off, it means your table is in imperial units. Okay, so metric being, of course, probably centimeters and liters, and imperial meaning not metric, that it would be in inches or gallons. Okay, let's look at the output side of things. Now, the first output is a Boolean that is just an error bit. So it's on if there's an error. What kind of errors could you have if you've improperly entered your table? Maybe you entered a table or you specified a table size that was greater than 100. Well, we can only handle tables of 100 or less. Okay, so that would be an error. Another error might be that your volume data was not in ascending order. Remember, when you're looking at that table, as your inches are ascending, and your volume should also be ascending in terms of liquid level and number of volume of your liquid. And if it's not, that would be an error. So there's a couple possibilities there where you could have an error with this function block, but that would be flagged with that Boolean output. And then the other three outputs basically are the number of gallons in the tank, and the number of liters in the tank, and the fill percentage of the tank. Okay, and these are all real values. So if your table's in gallons, you're going to get gallons and liters out. If your table's in liters, you're going to get gallons and liters out, that sort of thing. Okay, so that's the output, what the outputs look like for our user-defined function block. Now, what are the steps that are going to be involved to actually use this function block? Okay, I've talked about the inputs, I've talked about the outputs, I've talked a little bit about what's happening behind the scenes. Basically, here's the steps that are going to be involved. And we're going to show you a lot about this UDFB, but we won't show you each of these specific steps. Basically, what you're going to do is you're going to import the UDFB into your Cscape project. You're going to create variables in your program variable window for each of the UDFB inputs and outputs. Okay, and we reviewed those over the last two slides. Next, you're going to add an instance of the UDFB to your logic program. Now, you're going to find those UDFBs that have been imported in the project toolbox, and we'll show you that in the demonstration here in a minute. Now, each time you add one of these function blocks to your logic, and let's say you have 6 tanks, and you want to add this function block 6 different times. Every time you add it, you have to assign a name to that, a unique name to that instance of the function block. So if you had, 6 tanks and they were labeled A through F, for instance, then you might name your function blocks tank A, tank B, tank C, tank D, etc., etc., etc. Okay, but each UDFB instance has to have a unique name. And then once you've added that instance and named it, then you're going to just effectively fill in what are the input variables that need to be assigned to that UDFB and what are the output variables that need to be assigned to that UDFB. So those are the basic steps. Okay, now one question you may have is, how in the world am I going to enter the data from the data table, the manufacturer's data table that I'm using? How am I going to enter that as ladder logic? That would be something that you might have a hard time getting your head around there. Well, basically, I mentioned the fact that for each column of data, the inches column and the gallons column in the example I've got here on the screen, you're going to use a constant move function block to enter in all the data in that column. So if I were to read down the inches column right now from that chart that's on the screen, you'll see it's just in numeric order. 1, 2, 3, 4, 5, 6, 7, etc. Okay, so that's the data from 1 to 27. You're going to be listing in that first constant move. In the second constant move, that's the gallons data or the volume data, and you can see the numbers there. At the top would need to be entered in order, are 6, 14, 22, 31, etc. Okay? And then I also mentioned before that a third input that needs to be specified with our user-defined function block is the number of data entries in the chart, basically the number of rows. You count those up and then you enter that as another input, just as an integer input. And again, my example, that number is 27. Now, one thing I want to mention here, and that is this. This particular chart you see on the screen here starts at a non-zero value. In other words, the first row is not 0 inches and 0 gallons. But I've seen both ways. I've seen some manufacturers that provide their data chart where the first row is, 0 inches and 0 gallons or 0 centimeters and 0 liters. And then they go up from there. And a lot of them, though, I've seen are like the one here on the screen, which doesn't start at 0. This particular user-defined function block can handle both cases. So whether the chart starts with 0 or not, it's going to be able to handle it. Okay, so enough of the slides. Let's dive into our Cscape program and show you how to use our new user-defined function block. So here I am in Cscape, and this is my example program utilizing this new user-defined function block we've been reviewing. Okay, so let's start with importing the user-defined function block. How did I do that? Well, I went over here to Logic Modules, right-clicked, and said Import Logic Module. Then I navigated to the location where my logic module, my UDFB file was located. It's a CPU file. Once I typed in star.cpu, it showed up here. I then hit click and open, and it added it to my project. Now I did that previously, so I'm not gonna do that again. Once it loads, it shows up here under UDFB modules. And then when you wanna actually use it, it also shows up over here under your project toolbox at the very bottom under UDFBs. Okay, you can see all the UDFBs will show up here. And here's the tank volume table UDFB right there. Okay, and then when you go to add it to your project, basically what you're going to do is you're going to click and drag it to your project. Okay, and you're going to assign it a name. Okay, so let's call this gas tank 2. All right, we hit OK. And then immediately after naming gas tank 2, it opens this dialog box so you can assign all of the input variables and output variables to this user-defined function block. And I would recommend that you create those ahead of time and then basically just browse for those tags right here. Okay, so that's what I would do when importing, or basically when dropping a new instance of a user-defined function block in my program here. Okay, but I've already done this. All right, so I'm gonna hit cancel here, and you can see that function block went away. And now I'm gonna show you an instance of this user-defined function block that I had previously placed here in my program. And it's already been assigned with all the variables. These are the input variables here and the output variables there, all right? Remember, these first two variables are actually real-based arrays, okay? That contains the level data and the volume data. We've got our integer variable that tells us how many tank chart entries there are. In my case, there were 27. Your case will probably vary. This is the variable that specifies what is the fill level coming in. And if your chart's in inches, then this gas fill level needs to be in inches as well. This is another real variable. And then are the units metric or not? Always on would indicate yes, it's metric. Always off would indicate no, it's not. In my case, it's not. And these are our output variables. Gallons, liters, and fill percent are all real variables. And then the error output is a Boolean variable. Okay, so that's the input and output variables that I have assigned to this instance of the user-defined function block. All right, and then all that's really left in terms of the application is getting the data from our data table from the manufacturer of the tank into these arrays that were specified. And we do this through the constant move function blocks right here. So let me double click on the first one, which has our level data. Remember, that chart had 27 entries, and these were just in even 1-inch increments in my example. So 1, 2, 3, 4, 5, 6, 7, 8, you just enter these all in order until you're done in one function block, nice and easy. And it tells you you've got 27 items in your list, which matches what we want here. And then similarly, this is our volume data, and this is the data in gallons from our chart. And again, we had 27 entries here as well that I entered in one after the other. Okay. So that's really very easy to add that table data in there. And that's really all there is to setting up this particular function block. Really pretty easy. Now I've created a screen that I can use to kind of exercise this demonstration. So let's go ahead and go to the bench now. All right, here is my X7. It's the Micro OCS X7 that I'm running this demo application in. You can see I've imported a picture of the tank along with the data table. That's just a picture of the data table, all right? And then for my demonstration, I'm going to have the ability to enter in manually what the tank level is. Now, of course, in a real application, that's probably going to come from some sort of sensor, maybe a ultrasonic sensor, and you'll have to do a little bit of math in your program to convert that value, that analog value coming in from your sensor, or maybe it's coming in over a network, but either way, you'll have to convert that value over to either inches, which is my example, or centimeters if that's what your table is in. Okay, so that's normally the logic you would add in your program. Here, I'm just going to manually enter in the value in inches. All right, and then it's going to spit out how full the tank is and what the number of gallons and liters are. Okay, so let's just go ahead and do this now. I'm going to put in, starting with, let's say I'm going to simulate a tank value of 5 inches of liquid. That corresponds to 41 gallons, as you can see. And if we look at our chart here, we can see that, yep, at 5 inches, that's 41 gallons. Now, let's say that we are at 25.5 inches as our level. Okay, so now we go down here. 25 is 260, 26 is 268, and sure enough, we're halfway between those two at 264. So the linear interpolation that we're using in this function block is working just fine. And throughout, we're also getting how full the tank is, as well as how many liters this represents as well. Now, you'll notice this particular table starts at a non-zero value for the first entry. So what if we have, let's say, 1/2 inch of liquid in this tank? Let's type in 1/2 inch. Let's see if it handles that properly. So at 1/2 inch, we've got 3 gallons. Yep, that looks right, because at 1 inch, we've got 6 gallons. So with the linear interpolation, we end up with 3 gallons. So this appears to be working just the way you would expect. And as you saw, there wasn't that much work involved in taking advantage of this user-defined function block. That does it for our topic today. Don't miss an opportunity to earn a free controller. If you submit a case study to our marketing department that details one of your recent applications using an Excel Prime, Canvas, or OCS.io product, then you can win a free controller. So contact our marketing team today. Still plenty of time to sign up for OCS training in 2025, but don't wait too long. The slots will fill up. Now, this is absolutely trade show season. Between now and mid-June, we are going to be all over the United States, and you'll have an opportunity to see me, if you so are interested, at the Automate show in Detroit. That's coming up in mid-May. There's an opportunity there to see lots of Horner products in action. Lots of ways to interact with Horner online at hornerautomation.com. You can also find us on our YouTube channel and on LinkedIn. Now, next week, we've got an interesting topic. What we're going to be doing is we're going to be reviewing all of the free function blocks, basically all the free UDFBs that we have created over the past several years. We're going to review them all quickly in one session. So this is a way for you to see what user-defined function blocks are available that you could use in your next project. So these are free. You just download them and use them, and it can save you a lot of work. So next week, you'll be able to see which ones are available and which ones you should be using in your next project. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do some good.